So now we are going to see that a current carrying loop. Loop now or closed conductor. PQRS is a closed conductor. When the conductor is closed and it is placed in the uniform magnetic field, what is the force experienced by the closed loop? So torque experienced by the current loop, rectangular shape, in uniform magnetic field. So uniform magnetic field வைக்கும்போது நம்ம என்ன force act பண்ணும்? இது வந்து ஒரு சார்ஜ் கிடையாது, ஒரே ஒரு லென்த் கண்டக்டர் கிடையாது. It is a closed loop. PQRS is a closed loop. Okay, so see that force experience, we can divide that into 4 segments. See, PQRS. PQ is on one side, QR, RS and SP are the 4 sides of the rectangle. And length of the rectangle, we can take that the PQ and SR is equal to L. PS and QR is equal to breadth of the rectangle, that is rectangle at the B. So now we can initially see that when the current is flowing through the conductor, it experiences the force of F is equal to BIL sin theta. That's already we know that. So in that SP is the S and P. The force acting on that S and P here. So S and P. So first we are going to take that S and P, that this side. So the breadth of the conductor. So we are going to take the breadth of the conductor that we are going to take. So in this side F is equal to BIL sin theta. So this is the force experienced by the conductor, that is PS in this direction. Another one QR. QR is its bottom. Again the same value FQR equal to BIL sin theta. So FPQ. PQ is the other side. See this side. So PQ equal to F equal to BIL sin theta. Sin 90 becomes 1. So that's why we are writing F is equal to BIL. So FRS. RS also the same value F is equal to BIL sin theta. அப்ப 4 கண்டக்டர் 4 சைடு எடுத்துக்கிட்டோம் அப்படினாலுமே எவ்வளவு வருது நமக்கு? These two forces are equal. So PQ and this one. And here also the two forces are equal. That is PS and QR side. So here upward force and downward force also equal. And this force and the opposite force FPQ and FR is also equal. So see here that upward force and downward force are equal. மேலே கீழேயும் force equal. அப்ப என்ன பண்ணுது? The two forces are cancel each other. So two equal forces acting in opposite direction, they cancel each other. அப்ப மேலே கீழே ஒரு force equal ஆக்ட் பண்ணும்போது என்ன ஆகும்? ரெண்டு ஒரே அளவுக்கு இருக்கும்போது equal ஆயிடும். அப்போ cancel ஆயிடும். But that other side, see that here the two forces are not in a same direction. It's an opposite direction. So the two forces acting in the opposite direction, they are constitute a couple. That means it experiences the torque. நம்ம பல தடவை பார்த்திருக்கோம். ரெண்டு force act பண்ணுது அப்படின்னா ரெண்டுமே வந்து opposite direction இருந்ததுன்னா it constitute a couple. ஒரு rotating effect வரும். That's called torque. அப்ப torque எப்படி calculate பண்றது? We know the formula of the torque. Torque tau equal to any one of the force into perpendicular distance. Here Pn is the perpendicular distance between the two forces. So RS and PQ. அது ரெண்டு நடுவுல இருக்கிற கேப் வந்து இதுதான். அப்போ FPQ equal to, we can write any one equation BIL. Pn equal to B cos theta. So Pn, this இது வேணும் அப்படின்னா வேணும், that is equal to B cos theta. So here torque tau is equal to BIL B cos theta. So here length into breadth. So length into breadth என்னது? Area of the rectangle. So length இந்த பக்கம் இருக்கு, breadth இந்த பக்கம் இருக்கு. Length into breadth will give the area of the rectangle. So L into B we can write written as A, that is area. So here torque tau is equal to NBIA cos theta, where N is the number of turns. இங்க ஒரே ஒரு டர்ன் எடுத்துக்கிறோம். சப்போஸ் N number of turns இருந்ததுன்னா torque tau is equal to NBIA cos theta. Okay. So here suppose that angle of between the normal coil and the direction of the magnetic field, theta plus phi are 90 minus theta. இதா இருந்தா என்னவா மாறும்? நமக்கு cos theta ஆதான் மாறும். So torque tau is equal to NBIA cos 90 minus phi equal to sin theta. இது என்ன? இது நமக்கு வந்து 90 minus phi or 90 plus phi வருதுன்னு வச்சுக்கோங்க. இங்க பாருங்க, இது வந்து இன்சியலா இருந்த டைரக்ஷன். அப்ப இது என்ன ஆயிட்டு இருக்கு? கொஞ்சம் ரொட்டேட் ஆயிருக்கு, சாஞ்ச மாதிரி இருக்கு இல்லையா? இப்ப இது நார்மல் அப்படிங்கிறது என்னங்கிறது வந்து காயிலோட டைரக்ஷன். ஓகே, இப்போ பி அப்படிங்கிறது மேக்னெட்டிக் இண்டக்ஷன். ஆரம்பத்துல இங்க இப்போ இங்க இருந்தது. அப்போ காயிலோட நார்மலுக்கும் மேக்னெட்டிக் இண்டக்ஷனுக்கும் நடுவில் இருக்கிற ஆங்கிள் பை. அப்போ what is the angle between the I and B? I and B அப்படின்னா that is the current element. அதுக்கு நடுவில் என்ன இருக்கும் அப்படின்னு கேட்குறாங்க. அப்போ எந்த ஆங்கிள்னா இந்த ஆங்கிள் நமக்கு வேணும். ஸோ எது? ஸோ திஸ் ஆங்கிள். ஸோ ஆங்கிள் பிட்வீன் த கண்டக்டர் அண்ட் த பி. அப்போ இங்கிருந்து இங்க வரைக்கும் பார்த்தீங்கன்னா the total degree is 90 degree. ஸோ 90 minus 5 will give the direction of this one. ஸோ இங்க என்ன வரும் அப்படின்னா நமக்கு ஸோ 90 minus 5 will give the angle. அப்ப அதான் இங்க 90 minus 5 வந்திருக்கு. அப்ப இதே இங்க பாத்தீங்க அப்படின்னா நமக்கு இந்த ஆங்கிள் வேணும் அப்படின்னா ஸோ 90 பிளஸ் தீட்டா. இப்ப எனக்கு வந்து இந்த ஆங்கிள் வேணும். அப்ப இங்க என்ன வருது? இது பாத்தீங்கன்னா 90, இங்க இருந்து இது வரைக்கும் இருக்கிறது 90. அப்ப 90 பிளஸ் தீட்டா இந்த ஆங்கிள் நம்ம கண்டுபிடிக்கணும். அதாவது the direction between the flow of current and the magnetic induction. இப்போ இங்க பாத்தீங்கன்னா 90 பிளஸ் தீட்டா அப்படிங்கிறது இங்க, 90 மைனஸ் தீட்டா அப்படிங்கிறது இங்க. So 90 plus theta or 90 minus theta, whatever it is, you will get that sin theta. So final equation tau is equal to NBIA sin theta. So NBIA sin theta அப்படி நம்ம எடுத்துக்கலாம். Right? So next one. So NBIA sin theta அப்படிங்கிறதுல direction பாத்தீங்க அப்படின்னா n cap அப்படின்னு போட்டுக்கலாம். So tau is equal to Ni into A cross B, where A cross B, that area into that current, moment of inertia அப்படின்னு சொல்லுவோம் நம்ம. Moment of inertia of the magnet, magnetic moment, sorry, magnetic moment equal to M equal to I into A. So அப்ப I into A னா இங்க IA இருக்குது. இங்க பாத்தீங்கன்னா இங்க தெரியும் உங்களுக்கு IA இருக்கு. But tau is equal to N M B, where M is the magnetic moment. So இதனுடைய பாத்தீங்க அப்படின்னா எப்போ வேல்யூ மேக்ஸிமம் இருக்கும் மினிமம் இருக்கும் அப்படின்னா, so it's a cross product. So you will get that tau equal to NBM into sin theta. When sin theta equal to 0, the total term becomes 0. So the tau is tau equal to 0. Suppose 90 degree, the angle between the current and magnetic induction is 90 degree. It experiences the maximum torque of tau equal to NIAB அப்படின்னு கிடைக்கும். So the above formula for torque can be used for any loop irrespective of its shape. எந்த ஷேப்பா இருந்தாலும் சரி இதனுடைய இதை நம்ம யூஸ் பண்ணலாம். இது வந்து ரொம்ப ரொம்ப இம்பார்ட்டன்ட். உங்க புக்ல பாத்தீங்கன்னா அதுல IJK அப்படின்லாம் கொடுத்துருப்பாங்க. IJK அப்படிங்கறதுலாம் என்ன அப்படின்னா அதனுடைய டைரக்ஷன், எக்ஸ் ஆக்சிஸ், ஒய் ஆக்சிஸ், இசட் ஆக்சிஸ். எக்ஸ்னா ஐ, ஒய்னா ஜே, இசட்னா கே அப்படிங்கறத கூட தேர்ந்திருப்பாங்க. தட் இஸ் த டைரக்ஷன். ஸோ அதை போட்டா கன்ஃபியூஸ் ஆகுமே அப்படிங்கிறதுக்காக நான் உங்களுக்கு சிம்பிளா சொல்லியிருக்கேன். ஸோ இப்பவும் பாத்தீங்க அப்படின்னா எகைன் அதே கொஸ்டினை திரும்ப நம்ம பார்க்க போறோம். ஸோ அது கொஞ்சம் பெருசா இருக்கிறதுனால இன்னும் கிளாரிபிகேஷன் வர்றதுக்காக இஸ் அனதர் மெத்தட் ஆஃப் the torque on a rectangular current loop in a uniform magnetic field. So see that. So it is a magnetic field. When conductor is placed between the magnetic field, it experiences a force according to the Fleming's left hand rule. So the torque is acting in a downward direction according to the Fleming's left hand rule. So if you கையை வச்சு பாத்தீங்க அப்படின்னா உங்களுக்கு தெரியும் F is equal to BIL sin theta. So the direction of force is acting downward direction according to the Fleming's left hand rule. So this is for only one conductor, one length conductor. It's not a loop. It is a conductor. So theta is the angle between the conductor and the magnetic induction. So this is the angle between the conductor and the magnetic induction. Okay. So the current in the direction according to Fleming's left hand rule, it indicates in the downward direction. Right? Now you can see that set close to PQRS. Okay. That PQRS is placed in the between the magnetic field. It is a closed loop PQRS. So that is length of the conductor and this is the breadth of the conductor. So see that it is the plane. This is the plane of the coil. The PQRS. That is connected to the battery. So the battery is connected to the PQRS. Current flow from the battery to the closed loop. It is flow from the direction of PQRS and again it is PQRS. Like that, that current is flowing through the coil. It's a closed loop. Okay. So that coil current is flowing through the coil. So current flow through the conductor is placed in a uniform magnetic field that acts as is equal to P. Now you can see the current flowing in the conductor and placed in the uniform magnetic field that acts on the coil is that's P. So see that the length of the conductor PQ, that is 90 degree. That is angle between the conductor and the magnetic field. So sin 90 equal to 1. We know the formula for the conductor force on a conductor PQ equal to F equal to BIL sin theta. So here sin theta equal to sin 90 degree. So F1 equal to BIL because sin theta becomes 1. So F1 equal to BIL. That is the force experienced by the conductor PQ. Okay, according to the Fleming's left hand rule, the force acting in the downward direction. See that the finger thumbing indicates the downward direction. So we can take the equation is 1. Now we can take that another side of the closed loop. So forefinger indicates the magnetic field. See that forefinger indicates the magnetic field, and middle finger indicates the direction of flow of current, and thumb finger indicates the direction. So the direction is in the downward direction. So see that green color line. So the coil F1 force is acting in the downward direction. Okay, this is for the conductor PQ. Now QR, that is the length of the breadth of the coil B, that we are going to take B QR, that is placed between the magnetic field. So current flowing through the conductor from Q to R. See that angle between the conductor and the magnetic field is 0. So we have to put sin theta equal to 0. So sin 0 0, the total force F2 becomes 0. So there is no force is acting on the side of the coil QR. There is no force acting on that side QR. So F2 equal to 0 because that conductor is parallel to the magnetic field. Now SR, the RS, that angle is between 90 degree, the conductor and the magnetic field. So sin 90 means, you know that sin 90 equal to 1. So the force experienced the maximum F3 equal to PIL. So that is the force experienced by the conductor. So here also, according to the Fleming's left hand rule, the force acting in the upward direction. F3 is acting in the upward direction. See that angle? So F3 force acting in the upward direction. Now the last term, PS. Again you see that the PS is parallel to the magnetic field. So theta becomes 0. Okay, that is 180 equal to 0. So direction, see the direction with the magnetic field. So sin 180 is always 0. It is parallel to the magnetic field. So sin 90, 180 equal to 0 means F4 is also 0. So PS side also there is no forces acting on the PS. So F4 is also becomes 0. So there is no forces acting on the two side QR and the PS. Only the two forces acting on the side of PQ and the RS. So acting in a opposite direction. One is in a downward direction, another one is in a upward direction. Okay. So see here, F1 is acting in a downward direction. F3 is acting in a upward direction. So the two forces are acting in a opposite direction. Remaining two sides, there is no forces acting on that. So equal and opposite forces are acting on that. So it will experience the torque, that is rotating effect. So it will rotate in a anti-clockwise direction. So it experiences the torque. See that how it is rotating. It's rotating in the anti-clockwise direction. So it experiences the torque. Torque tau is equal to, you know, the formula. So that coil is rotating in the anti-clockwise direction. Torque tau is equal to force into perpendicular distance. It's already you know that. So we can take any one force into perpendicular distance between the two forces. Okay. So you can take F3 or F1. So tau 1 is equal to F into B by 2. That is triangle there. So tau 3 equal to F3 into B by 2. That is perpendicular distance. Perpendicular, when you draw the diagram means you can easily understand that F1 means the any one of force, the distance is B by 2. So total torque equal to tau 1 plus tau 3. So total torque tau is equal to, you are adding the two values, you will get. So F1 is equal to F3 because two poles are equal. So F1, F3 equal to, and adding the two value, you will get F equal to BIL. So B torque is equal to BIL into P by 2 plus BIL into P by 2. Finally, you will get BI into L into B, where L into B is the length into breadth. So length into breadth, you know that is equal to area. So instead of L into B, we can write area of the soil. Tau equal to BI into A. So this is the start experienced by the soil of the F3 and the F4. That is upward and the downward flow. So due to that, the coil is rotating in an anti-clockwise direction. So take the torque of this value. This is for only one third. So only one conductor is there. Whatever conductor it's it has only one third. So torque experienced by the torque is equal to BIA. So according to the Fleming's left hand rule, see that. This is for the axis of the coil. So the right hand thumb rule, you can use the right hand thumb rule, not Fleming's left hand rule. So the thumb finger indicates the direction of the force. That is perpendicular to the area, the current flowing through the conductor. So we know that right hand thumb rule, when you close the form, the thumb finger indicates the direction of magnetic field and fingers are indicating the current flowing through the conductor. So torque thumb is equal to I into A into B, or you can write BIA sin theta. It is an ordinary vector, cross vector, cross product of the vector. Magnetic moment M equal to I into A. So we can simplify the equation. Torque tau equal to MB sin theta. You can write that instead of IA, you can write F. So unit equal to ampere meter square, the magnetic moment. So magnetic moment equal to I into A. So torque tau equal to M into V. It's a cross product. Or you can write MB sin theta. So torque tau equal to MB sin theta. Suppose theta equal to 90 degree, that is perpendicular to each other. Sin theta becomes 1. So it experiences the maximum torque. So the coil experiences the maximum torque when theta equal to 90 degree. Torque tau equal to M into V. Now you see that it is not a 0 or 90. Suppose it is an angle theta. So the angle between the magnetic field and the coil, that is not a 0 or 90 degree. Suppose you can take that is a theta. Theta is the angle between the coil and the magnetic field. Or coil, I can take the surface area of the coil to the magnetic field. That's taken as a theta. So what is the force experienced by the conductor when current flow through the PQ turns? So for that we are going to do the calculation. So what is the force experienced by the coil? See, when the current flow through the die, that is 90 degree, but it's in a theta. It is force on a P. The force on a PQ, we can write F equal to BAL sin theta, that is 90 degree, it becomes F from that becomes 0. Because perpendicular, that is perpendicular to the angle, perpendicular to the magnetic field. So it is acting in a downward direction. So slightly the coil is rotating. We are not going to take that surface area is 0 or 90, but the PQ side is always 90. So that is F1 dash, it becomes BIL. The same way, now we are going to see that other side. The other side of the coil. That is 90 minus theta. QR is not parallel. It's not a parallel. So it is 90 minus theta. It has some angle. That's why we are writing sin 90 minus theta. F2 dash. Initially we are taking this. It's a parallel, so we have to 0. But here it has an angle theta. So 90 minus theta become a cos theta. So F2 dash or B cos theta. That QR side. So QR side, see that using that right hand thumb rule. So the thumb finger, the extended thumb finger indicates the direction, and the fingers are indicating the current flow to the coil. Already we know that it's the right hand thumb rule. Right hand thumb rule. So F2 side, F2 dash equal to BIB cos theta. Initially we put 0 there because QR is parallel. Now it's not a parallel. It has an angle at theta. Now we are going to see the other side of the angle, that is RS. RS it is 90 degree. It's no problem. So again you will get the sine 90 equal to 1. So F3 dash again you will get BIL. Same way. Okay, so that's what changing that F1 and F3 are equal, and F1 dash and F3 dash have the same focus. Experience the two direction. Okay, it is in a four direction. Okay, F3 dash in the upward direction, F1 dash in the downward direction. According to the film means left hand rule. Okay, now that F4 dash, the both side of the coil PS. So we again see that it is 90 minus theta. So total 90 degrees is 90 minus theta. Suppose on that SP, it is not a 0 or 90, it's 90 minus theta. So 90 minus theta again, it will become a cos theta. So F4 dash, you can write F5B cos theta. So F5B cos theta is the equation number 8, which is number 8. So again, it is according to the right hand thumb rule. The extended thumb finger indicates the direction of magnetic field, and fingers are indicating the current flowing in the coil. So F2 dash and F4 dash is acting in the opposite direction, but it's a collinear. This is acting in the same line. So same line is acting in the opposite direction means you know that definitely the two forces are equal and opposite. It will become 0. But F3 dash and F4, F1 dash is acting in the opposite direction. It constitutes a couple, you know that. It is not a collinear. But F2 dash and F4 dash is a collinear. It's acting in the same line. So it's acting in the same line means definitely the resultant force becomes 0. The two forces are acting in the opposite direction. So that is indicating in the diagram. See that the green curve line acting in an opposite direction. F2 dash and F1 dash. So there is no torque on the two sides. But F3 dash and F1 dash experiences the torque. That's two forces equal but acting in an opposite direction, and it's not a collinear. Not collinear means it's not in the same line. Okay, it's not a collinear, it's not the same line. So the experience of the torque. So torque means you know it is a rotating effect. It's moving in an anti-clockwise direction. The green arrow mark indicates that we are moving in an anti-clockwise direction. So see that the distance between the two forces. We are going to take the torque. We are going to calculate the torque. So torque equal to again the same force into perpendicular distance. We can take any one force, F3 or F4, F1 into perpendicular distance. The perpendicular distance is see that length of the side divided by 2. See that the blue color line indicates in that length. So D equal to that red color line. See, linking that red color line. That is the distance that we can take B by 2, breadth by 2. So total length is breadth, the half of the length is B by 2, cos 90 minus theta. So you can write D equal to B by 2 sin theta. That other side from center to that point. That's also a diagram tau 1 dash equal to F1 dash B by 2 sin theta. That is for force F1. Same thing we can calculate in F3 dash also. So F3 dash equal to F3 dash, tau 3 dash equal to F3 dash B by 2 sin theta. So every tau 1 calculate பண்ணனும் அதே மாதிரி tau 3 calculate பண்ணனும். அப்ப total force அப்படிங்கும்போது total torque போது you have to add the two torques, tau 1 dash plus tau 3 dash. So it will give the total torque experienced by the coil. So substituting that value, torque tau dash equal to F1 dash B by 2 sin theta plus F3 dash B by 2 sin theta. So adding that two values, so you will get F1 dash equal to F3 dash equal to the two forces are equal. The same value, that is equal to F equal to BIL. So F1 and F3. So torque tau dash equal to, instead of F we are writing BIL B by 2 sin theta plus BIL B by 2 sin theta. So adding that two torques, finally we will get F equal to B, torque tau equal to BI, L into B sin theta, where L into B is the area. So torque tau dash equal to BIA sin theta. So that is the torque experienced by the coil. Torque tau dash equal to BIA sin theta. So that's the torque of the coil, not on whatever. So the coil is rotating like this. Suppose this coil is like this. So what will happen? So coil is perpendicular to the magnetic field. This is one complete rotation. The force is acting in the downward direction. Theta becomes 0. Sin theta 0 means the total torque becomes 0. Right? See that. So the force is acting on like this. Downward direction, torque tau dash equal to 0. Sin 0, the total torque is 0. So it is parallel to the magnetic field. The two sides are parallel to the magnetic field means the torque becomes 0. The two side means that length of the coil. The two length of the coil is now it's parallel. But two breadth of the coil is perpendicular, but the direction is opposite, collinear. So we are not able, we don't want to consider that. Two forces, F1 and F2 and F4. F1 and F3 is now parallel to the magnetic field. That's why the maximum torque tau dash equal to 0. So it's another method of doing the calculation for the closed loop. So very important.